Hi everybody, this is Al Berg. It's November 21st and I will be doing a video today on voter fraud. It uses some simple math and Microsoft Excel. And some things about me. I'm not a statistician. I've never actually taken a statistics course. I wish I had. If you're in school, take one. They're very useful. I am an Excel VBA expert, and so I use some of that skill to figure out how to do this. I worked in finance for many years, and I'm also the author of the book 33 Key Principles for Success, which you can get on Amazon. And I'm also the founder of the following companies. The latest one I'm working on is chirper.com, which is a social media platform. So for voter fraud, there's two methods that I know of, and I used this when I worked at a hedge fund, a fund of funds, and I'll talk a little bit about that. So the first method we're going to show is consecutive streaks, and in another video I will do something on Bedford's Law. There's stuff on Bedford's Law. I haven't seen things on consecutive streaks. So there's also other ways to detect voter fraud. You could look it up on Google. So my experience in voter fraud is that I did work at a hedge fund for a fund of funds, and we would get a bunch of fund managers would come in and they'd give us their returns. They'd say, here's how I did over the last and what this detection technique will be about is looking for consecutive streaks. For the data set, there's a few requirements. Number one is that it has to have less than 1,048,576 data points. That's this limit of one sheet of the number of rows. You could probably do something to make it work for bigger, but this is all this one does. And I need a vote timestamp. I need to see the actual sequence that the votes were done, and I can't imagine they don't record that. So I'm making that assumption that I'm going to get the votes in the order they were made. And I think there's some data out there. I've seen a couple of graphs that President Trump has tweeted showing that was big spikes at 4:30 a.m. or something, which is very suspect, very extremely suspect. Or it doesn't need a timestamp. If you give me the actual order of the votes, that's fine too. It's true. So when you flip a coin, one coin, it's assumed to be random, right? So, could be a two-headed coin, or it could be manipulated in a way that doesn't give you a random two sides. There's two sides to it. And of course it's possible to land on its side, but we're going to ignore that for now. It has heads and tails, and most people know that it's a 50-50 odds, which means it's a 50% chance of heads and a 50% chance of tails, and that's where the 50-50 comes in. So now what are the odds of two heads in a row, right? So you flip a coin. I mentioned that a little bit. So there's one outcome, two heads, and there's four possibilities. There's heads, 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 tails, tails, heads, and tails, tails. So that means it's a 1 in 4 probability, which is, if you do a division, it's equal to 0.25. And 0.25 is the same as 25%. So the odds of tossing two coins and getting two heads in a row is 25%. So it'll happen 1 in 4 times. And the odds of not getting it are 75%. So if you were to take a bet, that's a really good bet to take. It's always good to have a greater than 50% chance of winning your bet. And of course, the payouts also are important, because you could have very high odds and the payouts might be, there's a couple of trading strategies where you win 90% of the time and you win very small amounts, but when you lose a lot of money. So it is not just the odds that you have to go by. So, and the total odds is always going to equal to 100%. So the odds of what you want and the odds of what you're not going to get is going to total to 100. So flipping a coin, there's always a 50% chance of heads, and a 50% chance of tails. And in terms of flipping a coin, there's one outcome, It's either heads or tails, and there's two possibilities, which is again a 1 of 2 or a 0.5, 50% odds of heads and 50% odds of tails. Total odds are 100%. Okay, so the odds of 2 heads in a row. So you want to get heads, heads, and this is the outcome, and these are the possibilities. You can see here, there's 1 outcome and 4 possible combinations of heads and tails. Again, 1 and 4. So what's the odds of 3 heads in a row? So 3 heads, there's 1 outcome, and these are all the different possibilities. 1, 2, 3, 4. So there's 8 possibilities. So you have a 1 in 8 possibilities of throwing 3 heads in a row. And I think intuitively we know that the more heads in a row you have to toss, the harder it is. Now, on the other hand, if you tossed 100 heads in a row by chance, what are the odds you're going to toss a 101st head? And it turns out that these are totally independent events, and so the 101 is kind of telling me there's probably something wrong, but if it's a fair coin, the odds are still 50-50. So there's this slight interesting concept that flipping this coin after getting consecutive streak, it's only 50-50, but if you were to try and flip 100 heads in a row, the odds are astronomical that you would get heads in a fair coin toss. So if you didn't get this result, this expected result, then you know there's probably fraud. It's probably a fraudulent coin. Okay, so it's a 1 in 8, and you divide 1 by 8, you get 0.125 or 12.5%. So you have a 12.5% chance of throwing 3 heads. So what does that mean? That means if you toss 3 heads 100 times, and those 100 times 12 times, it'll come out in heads, and that's that's surprisingly high. So it shouldn't take you too long. So a question you could ask is, how long would it take to toss 3 heads, right? On average. I don't know the answer to that, but maybe we'll figure that one out. So what about 4 heads? So the odds are 1 in 16, and I think you're seeing the pattern. It's 6.6% chance. It's less and less and less. And the question is, do you see the pattern? So here's the pattern. 1 head is 1 in 2. 2 heads is 1 in 4. 3 heads is 1 in 8. 4 heads is 1 in 16. And I think you hopefully can see the pattern. It's a pattern that I did as a kid, adding 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16. And I wonder how many people actually did this pattern as a kid. Because I wonder, that shows me something. And I'm going to ask that question on the internet. So that's the pattern. So 1 outcome over the number of possibilities. So if you have a number of possibilities, we're going to multiply 2 times 2 times 2 times 2, and we do the multiplication of what's called a power. So it's 2. This would be 2 to the 4th power, 2 to the 4th. So that's how many possibilities there are in a coin. This is only for a coin toss. Each time you flip it, there's 2 choices, and we multiply them all to find out the total number of possible outcomes. So the odds of n heads in a row this is the formula: 1 divided by 2 over n, or 2 to the power of n. And in Excel we write that as 1 divided by 2, this caret n. This caret means it's an exponent. Some other languages use 2 asterisks, but that's how you do it in Excel. And all that means is that you want to do 2 times itself n times. So if it was 3 to the power of n, it would be 3 times 3 times 3 times n times, or 3 to 2 would be 3 2 times. So the question is, how many flips would you need to get 20 heads in a row? Which is an interesting question. So let's not lose track of the fact we're trying to determine if we have a fraudulent coin. And if the coin was fraudulent, the odds would turn out differently. So you can take the reciprocal to figure out, and the reciprocal is 1 divided by the odds. And that'll give you a list of how many flips you need to get 20. And so 4 heads, you would need to get 4 heads in a row, you probably, and again, this doesn't mean it's going to happen, but you have to probably flip the odds, 1 over the odds. So 1 over the odds of 2 to the 4 coins is 16. So you'll probably have to flip a coin 16 times to get 4 heads in a row. Flip 4 coins 16 times in a row. And the answer is actually 2 to the 20th. So you have to get 20 heads in a row. The odds are, the number of times you have to flip is just the number of sides times the number of consecutive ones. And you could do the same formula for other things, I believe. So I believe if you had 6 dice, you have 6 sides, and you wanted to get 26s in a row, it would be 6 to the 20th. Kind of makes sense. I'll have to do some calculations to see if that's right. Okay. So, and that answer is 1. Interesting that it's 1,048,576 to the 20th, which is the same number of rows in an Excel sheet. Isn't that crazy? And Excel is doing something with this 20 to figure out how many rows there are or something. Somehow it's using that number. So the Excel we're going to use formulas. We're going to use a statement called random between, which returns a random number between 1 and 100. If you want to do coin flipping, you can do random 1 to 1 comma 2, and 1 could be heads and 2 could be tails, and this is only going to get you round percentages when I'm going to do it. So if you wanted to go to get like 47.9%, and you don't know what I'm talking about, you would have to go up to 1,000. We're going to use an if statement, and in Excel an if condition. And again, if you don't understand any of these, watch what I'm doing, and then at the end you might understand them better, and then do a little research on the internet. I also at some point going to have classes on this. So we're going to do a condition, so we can say if random number is greater than 50, do something if it's true, and if it's false, do something else. So we're going to use that if statement. Very important in if. We're going to use exponents, as you've seen before. So a1 to the 3rd power is an exponent, and that really just means a1 times a1 times a1, and that's a1 is a value of the cell, and 3 is a number. And Excel is interesting of how you determine what's a cell. This is a cell name, and this is a value. And then we're also going to do a reciprocal, which I talked about shortly. That's going to be previously, not shortly. It's going to be 1 divided by some number. We're going to also use a count if. So the count if is going to look in column H in this case, and then it's going to look at the value of in R1. So cell R1 in this particular case could use any cell, and it's going to say how many times does the value in R1 appear in H1, in H, in column H. And we're going to use this count how many times, say, Trump was selected versus how many times Biden was selected. We're going to do percent calculations, 10%, 20%, etc., which is just some value divided by a total. We're going to talk about some coin toss probability and some calculations. We're going to do a sum, which just sums the range of cells. What's the sum of all the cells between x2 and x100, and that means the range. So it's x2, x3, x4, x5. We're going to see some E notation, which I might not get into much, but E notation is just basically a number times 10 to some exponent. So it's just a shortcut. So for example, if you wanted to represent a 1 with 100 zeros, it'd be hard to write, but you can write 1E100, I believe, in Excel, and that would give you the same number. We're going to use a max function also. So we're going to use that to figure out what's the maximum number of consecutive heads or votes. Let's do the demo. Okay, so I'm in the voting simulation small spreadsheet because the other one is really big. This is 180 something thousand bytes, 186,000, and the other spreadsheet, which has all the data in it, is 70 megabytes, 80 megabytes. So it's night and day. So let's just start with this. Let's go through what I have here, and I'll try to give some comments and commentary as we go through it. So first of all, we start with random between formula. So random between is going to give us a number between 1 and 100. And you see I just created one and copied it down. And you see it's the exact same thing here. And you see a random number. I'm going to press Shift F9, and that's going to do a recalc. And you see it just recalcs random numbers here between 1 and 100. And we're starting with 2,048 numbers. If I select the whole column, you'll see here it says 2,049, but we have one extra one, which is the heading. Okay, so there it is. So that's how you get a random number. You can put any number as the starting point and the ending point. If you want to do heads, tails, you can do 1, 2, 0, 1, or either ways you can do it. And I've done that. And for here, we're getting a random number between 1 and 100. If we wanted to do stuff with fractions, we would have to up that random number. But anyway, so let's continue. So the first and I've hidden columns A through F. I'm not sure. I started doing it. I had some stuff in the way, so just to keep it cleaner, I hid it. So you can unhide it. I don't know. So we'll see what's even there. Let's unhide that, just so. Just has a bunch of other columns. I probably should delete them. I don't see anything here I really need except for this. So I think I'm a little concerned that some of the formulas will stop working. So that's why I'm going to leave it this way for now. Okay. So we know what this is. A random number between starting and an ending range. You used to have to do a calculation based on random used to come between 0 and 1, and then you had to multiply and do an adds. But so they made it a little easier in Excel. So in the next column, column H, we have a first if statement. So, and we have also a difference between so we're going to test the value of G2, and that's relative mode. So as we make a copy, it'll get adjusted to G3, G4, G5, and let's just show you that. If I go down, you see how it's changing in the formula bar up here? So all I did was I just copied this. As a matter of fact, we're going to copy the last bunch of rows also all the way down just to make the sheet much bigger. So we're going to test if G2 here, and you can actually, if we press F2, it kind of highlights the cells it's dealing with. So if G2 is less than T2, and T2 is an absolute address, and maybe a better way to do this is to use a name, a range name. So just tells you what it is easier. Is T2, what does T2 mean? So basically, I have a calculation here, and I'll have to show you how that works. So if G2 is less than 50, less than or equal to 50, then it's going to be Trump. If it's greater than or equal to 50, it's going to be Biden. That's going to be 50-50. So from 1 to 50 is, if the random number is 1 to 50, it means somebody voted for Trump. And if the random number is between 51 and 100, that means somebody voted for Biden. Okay? And let's see how these numbers came from. So the only thing you really have to change on this spreadsheet is this one cell in yellow. So if I change to, say, 60, what it does, it adjusts this. This one is not really used because now, and what this is this is the results, the end results. So what was the result of the election? So say that in this particular county or state, Trump won 60 to 40. So 60 to 40 just means the random number. So when we simulate this, we're going to do a random number between 1 and 100, and if it's from 1 to 60, it'll be considered Trump, and if it's from 61 to 100, it'll be considered Biden. So we are going to look here. So here in this case, 41 is going to be Trump. Let's see, we'll just see if that worked here. 87 is Biden, 44 is Trump, 85 is Biden, 51 is Trump, 69 is Biden. So you can see it seems to be working. Okay, so that's this formula. This again is copied down. This is copied down. And then the next one is we're looking at, it's a little different. Okay, the first cell I have set up a little differently because I think, what I recall, I think it wouldn't work because this cell is a little different. So you see, here's 2 to 3. So if H2 is equal to H3, it's going to put a 1 here. Otherwise, it's going to put a 0. So it's basically looking for a duplicate pattern. So if you look here, Trump, Biden, no duplicates, and for the first duplicate we have here, it's going to put a 1. And then once it goes back to Biden, it's going to put a 0. So it's just looking, just a flag. It's called a flag. We're going to set it to a 1 if the previous cell is equal to, if the current cell, so if H11, which is the Biden, is equal to H10, we're going to set it to a 1. So we're going to set, as you can see, here's 2 Bidens, we're going to set it to a 1. 3 Trumps, 1, 1, 1. And this is going to allow us to calculate the next cell. And again, this one was just because of the first cell. So it's the only one that's a little different. And the next one, it just says 1. I just hard code this also because it's the same issue as the top one, which actually shouldn't be. But let's look at this one. So if I3, which is here, is a 0, then it just means there's no duplicate. Now, if I3 is not equal to 0, which it's here, 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 and here's the first time it's not equal to 0, we're going to say J6, we're going to add 1 to J6. So this is J6, we add 1, it's 2. Okay, so it's basically just, if you get a 0, it's setting it to 1, otherwise it's adding 1 value. So here we see 1, 2, 3, 4, 1, 1, 1, 1, 2, 3, 4. So what this is doing is, you could see it's just counting the number of consecutives. So we have Trump, Trump, Trump 4, Biden 1, Trump 1. It's just a count. And using a tricky formula that I figured out. So we see Trump, 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 and we can see it appears to be working. Okay, so then the next one, the next column, is we're going to say if J4, 1, is less than J3, so if it's less than, we're going to put a space here as long as the next cell, so J4 is this one here. So is J4 less than J3? The answer is no. So we're going to put a space here. So when this is false, we do this part. And we're going to go down and see the first time it's true. We see here, so is J8 less than J7? So here's J8. Here's J7, it is. So in that case, we're going to use J7. So this is just a way of finding the max count here. So if you look here, 2, it's pulling in 2, otherwise it's blank. Okay? And the next column up here is we're just doing a max of K, wherever K is. Where's K? So here's all the different consecutive counts, and we're just seeing that in this case we got 13. So there were 13 consecutive votes for somebody, and if I just press Shift F9, you'll see it'll change. 17, 12, 13, 12, 15, and I'm just pressing it. Now if you look on this table here, and we'll show you how this comes up. So in this particular case, we're going to change this back to 50-50 in a second. Let me change it to 50-50 now. Now I'm going to change this back to 50%. And just to make it easier for now. So in this case, I'll do a couple of more. 11, 15. So now, before I said we had 2048. Again, 2048. So 2048 is right here. So we would expect 11 consecutive. That should be around. And you'll see it'll vary around. 10, 15, 11, 12. And as the numbers get bigger, as you do more random numbers and computations, it gets more accurate. It'll come closer to 11 as the max. So does it tell me anything if the max is 50? It kind of does, because you probably could calculate the odds that it would come out as 50. And I'll have to do that. But in any case, and I do actually, the odds here to reach 40 are 1, and this is 1,000 million, or 1 in a billion. So for a 50-50 coin, if you were to toss it 40 times, the odds in a row and get heads, the odds are 1 in a billion. And I believe 50 is going to be 1 in a, I think it goes up by a factor of, let's pull this down to 50. It seems to go up by a factor of 10, which is pretty interesting. Oh, look at that. I did the exact. And you see it's up to the next digit, so it's up to and this is 1,000, million, billion, trillion, quadrillion. Is this a trillion? 1,000, million, billion, trillion. So 1 trillion. So it's 1 in a trillion to get 40 at 50-50 odds. It's a 1 in a trillion to get 40 votes in a row in this case. Now again, this is not totally accurate, because obviously 40 people could come in. They're all part of the Trump club, or the Biden club, and they all voted at the same time. But the likelihood of that happening is low too. So this is just something to keep in mind. So the number of votes in a row, if it's 50-50, it's really just basically the odds are 1 to 2 to the power of the number of consecutive votes. You shouldn't be seeing this. It's really a statistical anomaly, and when you see it, it doesn't mean it's fraud. It means it's probably fraud. So let's continue with this. Okay, so I explained how this, did I explain this one? And then basically the next column, we're just looking if case 6 is equal to null. So here, if this was null, we use null, otherwise we put the name from here, from H6. So we're just going to say, put all the names of whoever had the biggest streak. So this is the number, and this is the person's streak. Then, in the next one, we have Biden here. And so what we're going to do here is we're using the absolute formula of M1, which means we're going to use Biden, and you'll see that stays the same. And again, the first one's a little different. We're going to add M2, which is going to be here. We're going to add that to this if statement. So the if statement starts the same, so it's going to say if H2 is equal to M1, you want to put a 1 and 0. So we're just basically trying to count how many votes that Biden or Trump got. So you can see here, Biden, if you look here, I'm looking here and here. So we're going to look here and here. And as I go down, you'll see Biden 2, 3, 4, 5. So Biden got 5 votes in a row. And then since Trump's votes are here, Trump, he's got 4. And then you see Biden 6. So it's just counting. It's just tallying each time the vote. And the way we're doing that, we're adding the previous cell. And we're checking H3, which is here. So if it's equal to Biden, we're going to add 1 to the previous value. In other words, we're not going to add anything. And the same with Trump is going to be this very similar. So instead, we're going to add N2, which is up here. And if H3, the column here, is equal to Trump, we're going to add 1, we're going to add 2. So it's just basically counting. And if I go to the bottom, you can see that at 50-50, and we could shift F9. You see here, Biden, we got, so it's just totally random. And you see it's kind of flipping back and forth. Actually interesting that it is flipping back and forth. Okay, there it then. And you can see I actually calculated the, I'll go over this again, the actual percentages. So the odds, random I use is 50-50, and the vote came out 47.9 Biden, 52% Trump in that case. How many votes for Biden and Trump? Okay, so this is a running count of how many votes they each got. And I think I said that. Again, this is just the maximum streak. And I did have the total votes here. I don't know why this is blank here. You can just copy it down by double-clicking this little box here. And you'll see, just showing me the total votes. Actually, that's why I didn't have it. Oh, yeah. So this is showing me there's 248 votes. Okay, next. Okay, so now we're going to have some additional information here. So here's where we have who the person's voting for. You know, I don't know, with a 3-person election it might be a little different. So this is only for the two candidates, unfortunately. So we'd probably need a third, and fourth and fifth. But I'm going to leave that as an exercise to do later. So here you just enter. This is a calculation of 1 minus the cell. So again, if you add 90, you'll get 10%. And you see very quickly. So if 90% voted for Trump, the odds of getting a consecutive sequence becomes really easy, right? So to get 100 to get consecutive sequence for Trump's, you only need 190 tosses. As if the coin was 90% biased to go to Trump in this case. So if you got a lot of consecutive, and consecutive is almost impossible for Biden here. You see, very quickly, you need 10,000 votes, and just scales very quickly. So we'll go back to 50. Okay, now here's the number of consecutive tosses, right? Coins went through up to 50 now, and this is the odds, and the formula in this case is the same as that percentage, and then otherwise then it's the number it's the number Q2, which is the 50%, 0.5 times to this power. So this is Q2, 0.5 raised to the P7 power 2. So it's, and if we could, that doesn't help. Here it is over here. So you see over here, it's just the formula 0.5 to the different power, 2 all the way. And just for your information, I press Control, the quote, that funny quote next to the one side. And actually, let me make this a little bit bigger. Make it easy to see. I wish I had done that earlier. Okay. So, and you see, and we went through these numbers before. Here's 12.5, 6.5, and so it keeps getting in half. Now, to get the number of votes, to get that is you do the reciprocal, which is 1 divided by this number. Okay, so or coin tosses. So let's just talk about coins for now. So you have to flip a coin 256 times to get 8 consecutive heads. And if you wanted to get 20 consecutive heads, you'd have to flip it 1,000,000 times. So it's a very interesting thing. If you're tracking and it's not, then again, it's possible, but you're going to be suspect. And you see how it scales right here. It seems like every 10 you get another 1,000. Okay. Okay, so this is right now we're doing a counting of column H for Biden. R1 is Biden. So to count if anything in H is equal to Biden. So let's look at column H. And so it's counting all these Bidens. And in this case, there's 1,034. I could put a filter here. Yeah, I'm not gonna do. So if you wanted to see the actual count was for Biden, you could put a filter here and then select the column. Oh, okay. I'm not going to do it right now. Okay, so we got for Biden, there were 1028, but counting all the Bidens in column H. And the percentages is the total number of votes, which is R2 plus S2, which is these two. And you're dividing this value. So it's 1028 divided by 2048. And that is 52%. So in this random simulation, 50.2 voted for Biden, and just the same thing as here for Trump. And I have the same table here for Biden and the same table for Trump. Now, if you adjust this to 51, that adjusts, and the numbers change, the odds change. As you see, if we go down, just a 1% change, made a big difference in the odds. Look at that. To get 20 in a row, in this case by giving Biden giving Trump an additional. Probably should do blue and red. Actually, that's a good idea. Make it white, bold it, and let's center it. Okay, let's center it here too. And let's a little nicer. The red and blue is the color of the Dems and the. I could even set the colors here, but that's enough for now. Make it look a little nicer. We'll do it here too. Okay, so let's just continue. So, and you see it adjusts based on all the formulas. One of the beauties of an Excel is that you can change different variables. And let's say, so if it's a 60, the consecutive patterns, look at this. So for 20 in a row, yeah, so this is right. Oh, I got this backwards. Wait. It's not a good, this is not, if this is right, let's see, I think this is wrong. Okay, so Trump is at 60% here, and the odds of him getting 10 votes in a row. Wait, is that right? Okay, so it's a little bit bad, yeah. I'm going to switch these around. Okay, sorry about that. I flipped down and I've color coded it a little bit. So, okay, so now Trump at 60% of the total and Biden at 40% of the total. We can see to get 20 in a row, Biden needs 90 million votes. Trump only needs 27,000. So it just shows you how quickly you can detect fraud by even the results. So if it wasn't, if there were too many votes, just and it wasn't random, because it should be random, people coming to the polls, And again, let's say there's a lot of people coming to the polls and they're all Biden fans, and it'll show up. He doesn't need that many to get consecutive votes. But if it's 50-50, it's going to be very questionable. And of what I've seen, there appears to be these big spikes that came in at 4 a.m., which again is very questionable. But you know, it doesn't mean there's fraud, but it certainly appears there would be. Okay, so and these tables, you could just drag them down. You could resize if you get some big issue like that. And look at that. So to get 50 votes in a row for Biden, the odds are astronomical. Look at that. Okay, so and just the final look, we have a table over here on the right. We have consecutive, and this is just numerical 1 to 31. Okay, and the final table is showing Biden versus Trump in terms of consecutive runs. So Biden had 596 consecutive runs, like a flip of a head and then a tail, and Trump had 945, which makes sense. And you can see it's right there. Now for 2 consecutive, you see Biden had more 2 consecutive, and he's much higher here, but which would make sense because 10 consecutive is not counted as 2. And then as you see, as we go down, Biden, his last consecutive was 1 at 7 in a row, but you see his Trump here has 4 consecutive 7 things, and he goes all the way to 14. And then we could see a chart. Let's look at the chart. Hopefully it's working right. And this is showing how Trump, you can't really see it unfortunately, but which makes sense, 945. It might be better to show this as a percentage. But anyway, so now once you have that, if you get the actual election data, you can see that you can detect that as fraudulent. Then just one final thing, if you wanted to get this all down, you would just double click here, and I'm going to do it and then pause because this takes a long time. Let me save this first. And I'll double click here. I don't know if that's going to do it. No, that's not going to. What you got to do is you got to copy it. You got to control down, then control up, and then you control V. Okay, and that'll get us the voting. And I'll pause this while it's calculating. Okay, so what calculated is done. I've gone to the bottom of the spreadsheet, and you can see it's filled this in. And the only one thing you're going to have is this here, and we can just delete these. If you don't get rid of this, you're going to have a problem with some of the calculations if you go to the top. I'm not going to do that, but you'll see reference at the, okay, I will go to the top. We'll go Control Shift up, and then down, and then somewhere I should have a, maybe not. Okay, it looks okay. But anyway, yeah, right here, ref. The max doesn't work. Okay, so what you want to do is you want to go Control Shift down, and then you can just delete these. They're insignificant. Like that. To still be doing something. Okay, it's recalculating again because the max is, and you'll see here it goes. It's a little faster this time. You can see down here it tells you 4 threads. That means I have 4 CPUs on my computer. Okay, so that pretty much does it, and then you could play with these numbers to see what happens. I'd recommend turning off calculations that you can do by going here, options, formulas, and then do manual calculations. And you're going to press Shift F9 to do the calculation, to do the recalc. It'll give you a little bit more time. So if you want to, so you can change this to 50-50, and then examine the data. And I guess I should get the data from the New York Times or somewhere, and then put it in and see what it actually says. So that's it. That's it for this part of the video, and see if we have some more. And this is again going to be at, and so let me bring that up. So in summary, the spreadsheet's at chirper.com. I also have a book, 33 Key Principles for Success. If you go to https to do Amazon, you can see the book. And you could reach out to me on Twitter at Alec Berg, or Chirper. You can go to chirper.com. And you could download this spreadsheet at chirper.com, voting-simulation-small.xlsx. And to get the spreadsheet, you can go to chirper.com. And you might have to scroll down because there'll probably be more chirps, but you could go to 11/21/905, and the spreadsheet would be right here. So you can click that and it would open the spreadsheet for you. Anyway, please check out chirper.com, and you can also find my book, "33 Key Principles for Success," on Amazon. Well, thanks for watching. Please subscribe, leave a comment, like this video, and if you have any suggestions of future Excel videos you'd like to see, let me know. Take care.